Hey folks, so sorry. I thought I had made a mistake, but I didn't make a mistake. So I guess since I thought I made a mistake, stopped the lecture, and then in fact didn't make a mistake, still results in a mistake, right? So my apologies for the two split videos, but let's go back and let's come back to the results right over here. You'll see that this is showing that we have a linear relationship, right? This is our, what is this line called right here? I'll give you a second to pause. That's called the line of best fit, right? Remember we talked about our confidence intervals, 95% confidence intervals, that we wouldn't have to worry about it, but ultimately if any of these single observations fell outside of the confidence interval, then that means there would be an outlier, right? And notice that there aren't any outliers here, not at least to our visual operation. Our y-axis, shots made, and then our x-axis is the number of hours, and we can move these around if we need to. But let's come on over, and you'll see that, hey, this relationship looks linear, doesn't it? Okay. Let's carry forth, right? Let's move on. So the most important values that we're going to want here is from this table. So let's come over, and if you go back to your shots.xlsx Excel file, your dataset file, you'll notice that we actually have two tabs. So let's tab over to this model tab that I have created here. Notice I have the data. I've created a visual of this relationship. Notice that the R square, or R value, R squared value, it's not letting me move it, but is here. Let me go ahead and just show you how we can quickly create this one, right? Because sometimes it's just quicker to create this chart to see that whether or not this is linear, right? So remember, is the relationship linear? How do we know, right? Well, we know because when we run it in R, you'll see that everything is tight to this line of best fit. It's pointing in one direction, right? Remember, when we come back, this is not linear, but this is linear. Okay? So how do you know? You know because we performed a visual inspection. But how do we go ahead and create this figure in Excel? You highlight all of your data. You head over to Insert, and go to Scatter Plot, and then you can just hit Scatter. And notice it's going to go ahead and give you, let me zoom in a little bit. It's going to give you this point, right? So look, this is somewhat linear. You'll notice that our y-axis actually starts at 0. So we don't need the y-axis at 0. Let's format this. So I right-clicked on it. Let's bring the y-axis down to, say, 40. And notice how that drops it down. And in fact, there's no 50 point here, so we can do 50. That makes it even nicer. I don't like grid lines. Let's get rid of some of the grid lines. And then what we want to do is we want to add a line of best fit, right? So this might be a little bit different based off of your computer, but we go to Format. We go to, I believe it's Shots Made. Let's make the marker a little bit bigger. And then let's add a trend line. And notice now, by turning on trend line, that goes on, and then we hit display R squared value on chart. Send feedback. I like something, I don't like something, I have a suggestion. All right, I like it. Okay, so let's display the trend line. Oops, that was the equation. Although that might be useful. Let's display the R squared value too. And let's zoom in. And notice that the R square is 0.831. Okay. I just want to point out something too. We just so happen to turn on the formula, right? So remember how I had mentioned that I don't care what tool you use to go ahead and get the answer, whether it's SAS, whether it's a calculator, whether it's an online calculator, or if it's Excel. But let's see if anybody can look at these values over here, y equals 1.924x and 65344, where else you might find that. Okay, so minus a few rounding issues here or there. But the answer should be, notice that this equation is what SAS essentially had outputted. Okay, so again, once you have this figure created, XY scatter, you can just rewind this video and go through. And I realize that your version of Excel might be a little bit different from this one. So the things that you want to go ahead and Google is how to create a scatter plot, how to display a trend line, how to display R value, and how to display, I think it's called linear function. But watch this video and then Google those if you want to go ahead and try to make and recreate this figure. Okay, so now look, we're trying to, let's take a look at what our y-axis is and our x-axis, right? Our y-axis here is the number of shots made, and the x-axis is the number of hours practiced, right? How do we know this? Well, for one thing, the minimum number of shots made is 64. That's this point right here. The maximum is 89. That's right around here. That's probably this point right here, 89, right? Or no, sorry, rather 93. Look, 93 is this point right up here. And then the number of hours practiced ranges from 1 to 14, and you'll see over here, this is our x-axis, right? So we want to go ahead and say, if we practiced what was the question? 10 hours. If we practice 10 hours, how many do we predict, right? So if you had a student, now you have a whole different team, and you're saying, look, I have all this data. If a student practices 10 hours, and notice I put this here, then it's predicting that they're going to make roughly, according to our model, 85 shots. And you'll see that in actuality, it's 88 shots, right? So how did I just do this right over here? How did I create this little formula for you all to just be able to fill that in? Well, let's recreate it by ourselves, okay? So we're essentially going to have 4 points here. Oops. Okay, we're going to have 4 points here. Our intercept is 65.33395. Our coefficient for number of hours practiced is 1.98237. Number of hours practiced, well, that's up to you to put in, right? So let's just say 10 hours of practice. And now we're going to create a formula by saying equals, and now this is the formula, right? We're looking for the expected y, right? How many shots is this person going to make, given the number of hours that they practiced, right? So y is the estimated number of shots made. You start by saying equal B0, which is our intercept, plus coefficient times number of hours practiced. Okay? Coefficient is 1.98237, or B9, cell B9. And then number of hours practiced, we have it here as 10, or B10. And the reason why we did this, and notice how it says 85.15, right? Notice now I can change 10 and I can say, well, what if I practiced 1 hour? If a student practiced 1 hour, how many shots can I expect him to make? And notice our estimate says, well, we can expect him to make 67 shots. Okay? Now look, you can hand calculate this too. And this is fairly straightforward, and I encourage you all to go ahead and kind of hand calculate that one as well. So notice, here's our R-square value. Our R-square value is 0.83. What does that mean? What are our intercept and our first coefficients are B0 and B1. Well, that's these two right here, 65.33 and 1.982. Write out the formula for your regression model, and then how many shots are made for a player that practices 10 hours? 85. Okay? So apologies for having to split this up in 2 videos, but send me an email if you have any questions, and I will see you all next week. Bye.